All right, friends, welcome to week 4, lecture 1. Just so you guys know, once this week is done, you are halfway through the Python program. I know, time flies when you are having fun. But we are already halfway through, which is insane. That means we have also, after this week, we have 2 more weeks and our belt exam starts. You don't have to take it immediately, but our belt exam will start at that point. Let me pull that up for us and just kind of seeing what our next couple of weeks are like. What's happening here? There we go. Here we are on week 4. I did notice some of the kind of readings were a little bit changed in the sense of we said normalization and then tomorrow was belts, but then in order to do dojos and ninjas, you needed to read the belts already. So we actually just kind of shifted these by a day. That way we can introduce it all today. And then tomorrow you can really kind of start on your dojos and ninjas ERD. These first 2 days are ERDs, and it is a little bit confusing because you have a dojos and ninjas core here and a dojos and ninjas core here. I did put that in our email today that one is under the queries section and one is under the ERD section. They are 2 separate assignments. So please note that you do have 4 assignments with that. After this week, we are really starting to take what we learned in Flask, take what we've learned, or we're going to learn in MySQL, and we're going to mesh them together the next 2 weeks. So weeks 5 and weeks 6. This is going to be a ramp up, but this is going to be kind of the crux of what we're doing for this entire program, where all of a sudden we're doing some CRUD applications, which we're going to really learn about CRUD on Wednesday. And then the following week, we do just want to remind you, as always, Labor Day is observed. So we will not be having class on that Monday. We will have a back-to-back session Tuesday and Wednesday. And then Friday, your exam opens. Now, do you have to take the exam that first Friday? No. Do I absolutely encourage it? Yes. You get 3 chances to take the exam. So 3 chances. If you fail one, doesn't matter. If you fail 2, doesn't matter. If you pass the 3rd one, awesome. That being said, your 3 chances must be used by this Wednesday. That does not mean that if you get to Wednesday and you start your first exam, you don't have 3. You got however many you can fit in by the end of the day, Wednesday. So if you start in the morning and I grade it and then you start at night, totally, whatever. So that's usually why I say try to start the exam. I would say at least by this like Tuesday. Then I can grade it, get it back to you. If you need to retake, you've got Wednesday, Thursday, Friday, that entire weekend to do a retake. Then if you still don't pass, you still have another 2 days, 3 days to start your 3rd attempt. So that's usually why I say do that. Wesley, you have a question, my friend?
Yeah, I was reading over the belt requirements. In order to get a black belt, you need to be able to post your thing to the AWS. I cannot find instructions on how to do that
for deployment.
Yeah.
Let's go see. Belt review. Jax.
I would think it'd be in Project Week, but I didn't see it there either.
No, it should be here. Let's see. I will look into that because there should be. So like for, just to show you what it used to look like is we had this entire section called deployment. So you will have, I will make sure that by the exam time, you will have this key thing called deployment. And it is a fairly, it's literally right here to where we walk you through step by step, exactly what is deployment, using AWS, using GUnicorn, using Nginx. How do we get that set up? Here's what you run. Here's how you commit. It is a step by step. If you just follow step by step, we kind of teach you how to do it. So,
Okay.
yeah, I'll make sure that that's up. Sorry about that. That's great. Peter, you have a question?
Yeah, I was just going to forward the question that was in the chat, which was, are there any assignments that you'd recommend that we complete before the exam to give us like a good review of what we should be able to do?
Oh yeah, absolutely. There is a exam that we use as a, let's see, as like our
Mel
belt
mentioned.
prep.
Yeah. All right.
And it's this guy right here, this belt review, and it's called recipes. If you can do recipes, you will be just fine. This will be similar to what the exam looks like, where you will have to do a login and registration. Now, this is something that we are okay if you come to class, if you come to the exam with your register and log created, that's fine. It's okay. We're going to have an entire day on Tuesday, I believe, of week 6 is login and registration, where we build out registration and log in using password hashing, using validations, using all that stuff. So if you take that into the exam, we're okay with this stuff being built out. Then you're going to receive some sort of prompt, right? Whether it is, in this case, it's a dashboard and it's a recipes thing to where I can create a user, right? A user can create a recipe, I can edit it, I can query, I can see the recipe, et cetera, et cetera. Now, there are different things for the black belt, right? That if you are working through some of the stuff like email validation with database, private wall, that's a great one. If you're wanting to do a black belt, searching for these like added sensei bonuses, that's the kind of stuff that a black belt's going to come through. Here you can see this sensei bonus. It's going to look very similar to where you will have the breakdown of what you need to do for the red belt / orange belt. Again, the only difference between that is a red belt is done within 5 hours, and orange belt is done within 24 hours. And then you'll have the breakdown of the additional things on top of the red belt / orange belt material that you need to get done in order to get a black belt. And then again, a black belt does need to be finished within 5 hours. And then you have 24 hours to deploy after it's finished. So you don't have to do it all within 5 hours. You have, once the exam is done, that must be done, all the queries, all the functionality. And then you have 24 hours from submission to get it deployed. And then once you get it deployed, then you get a black belt.
Sure. So would you be basically submitting your files and stuff within 5 hours?
Mhm.
And then is the deployment like a separate link off to the side or something that you just...
Yeah, no, deployment is where you just send me your IP. So,
Okay,
so
okay.
you'll just
So you-
email me and say, hey, here's the IP address. And so
Gotcha.
I'll go to it. And then that's what I'll use typically to grade your exam,
Sure.
just to make sure all the functionality works.
Nice.
Great question.
Thanks.
Cool. So that's kind of what we're doing. But we still have a couple weeks. So if that stresses you out, don't worry. We do still have a couple weeks, 3 full weeks, right, of material. And then on that Friday of the 3rd week, then we kind of start. So don't worry about it. We are getting there. We are starting to slowly build though. So I'm just saying, if you've been putting off some of this material, I would absolutely really start ramping up because it's time. Just want to let you know that there are 4 core assignments for you guys this week. We have Dojos and Ninjas books, Dojos and Ninjas queries, MySQL countries. Now, in the actual, in this guy right here on the assignment checklist, it doesn't look like it's anything different, right? It just says Dojos and Ninjas, Dojos and Ninjas. One thing I do want you to notice is this one is the MySQL ERD section. This one is the MySQL query section. So there are 2 separate assignments for this. To where here, if I'm in MySQL, this is the ERD lessons. You have Dojos and Ninjas. And then if you go to the MySQL queries section, you have Dojos and Ninjas. So that is not a typo. You do have 2 different assignments. One is about queries. One's about just an ERD. And then lastly, I did want to point out, I did say it on Wednesday, but just wanted to reiterate that Mel is offering an extra office hour every Tuesday. Which is awesome. So that is here on this guy. Same Zoom room, correct, Mel? Yep, same Zoom room. But every Tuesday she wants to offer that. And our last Tuesdays was right here. So there's the link and then link for the last one. And then this Tuesdays, obviously the office hour will be posted right here for tomorrow. That is an optional thing, but come, it's at 6 p.m. PDT Pacific time. So come to that if you are needing help, if you're needing help with ERDs, if you're needing help with queries, come to this. Absolutely. It's a great time for that. And then just as a reminder, when we do get to Flask, we're not going to be touching Flask, really Python at all this class. We're really just going to be doing queries and that's it. But not this class, this entire week, we're not really touching it, but there is this Flask fundamentals there, the little cheat sheet that Mel made for you. Any questions on kind of what's going on and where we're going? Cool. All right, friends, let's just jump in. So this is something that I really love teaching because it's something that you're going to use no matter what language you have, no matter what program you're working on. Arguably, every single web application is going to deal with some sort of database. And that's where we're going to start today is we're going to start talking about databases. And in particular, we're going to talk about MySQL. Does anybody know what a database or why we would need a database? Like what does it do? Anybody have any idea? You can put it in chat or you can unmute. Organizes data.
Storage.
Go ahead.
Persistent storage.
Persistent storage. Okay. Yeah, I like that idea. Yeah, I mean, at the end of the day, it organizes my data and saves it to where I can retrieve it back and forth. Sometimes it's secure. If you just saw what happened with T-Mobile, it's not, right? But sometimes it can be secure. I am a T-Mobile customer, so I am appreciating the free stuff that they're giving out. Just the, small price of my social security number. But, right, it's a way that I can store some sort of data. And if we really think about kind of the future of tech or what's currently happening in tech, the companies that have data are the ones who are the, biggest companies in the world. Your Apple, your Facebook, your Google, right? Like TikTok. TikTok is one of the biggest data harvesters out there, right? And it's because with data, what we can do is we can do all sorts of things. We can decide where we want to put the next, McDonald's. We can decide what the next fashion thing is going to be. We can decide the price of the next monitor, or we can do all sorts of things. Where would the best, marketing campaign be done? And, X, Y, Z. With not only that, but we can do it from like a weather perspective. If we have weather data, we can do all sorts of different things with data. And I just love data because I think it's the future. And today we're going to be talking about a relational database. Now, there's two types of databases. Does anybody know what type they are? Anybody have a guess? I told you one.
The other one's NoSQL.
NoSQL, yeah.
Non-relational.
Non-relational, there you go. So NoSQL oftentimes replies to non-relational or not only SQL, because there are some things that you can run SQL queries. But yes, there's two types of databases to know, right? Or database structures in a sense. There's a relational database, which is what we're going to be working with. And then there's something called a non-relational database. So all of my friends here that are going to go on to MERN next, you guys are going to be dealing with MongoDB. And that is a non-relational database. And it really, the difference between the two are the way that they store data. So the way that a relational database works is it looks kind of like if you think about it, you can kind of look at it and say, well, that kind of looks like a, I'm trying to find the code here, like an Excel document. And it's because it stores it in a tabular way. So any relational database, in this case, we're using MySQL, but there are different ones, right? There are different SQL databases. That's not just MySQL. MySQL, the one that we're using, comes from Oracle, like where the Golden State Warriors used to play at Oracle Arena. But Oracle owns MySQL, but it does it in a tabular way, right? To where each instance, or here, let me draw. If we're looking at this here, I've got my columns and I've got a row, right? my columns in this relational database are my attributes of my instance, right? In this case, let's say I have a user. This user has a first name, a last name, and an address. Each row in a relational database is an instance, in this case, of a user, right? So each row represents a different user in my database. This is what we call tabular data, right? Because it is stored in tables. And so here is an instance of a relational database. Now, again, I said the word tabular data. Whenever a relational database is storing information, it stores it in a table. In this case, in this example, it's called customers. And this customer has an attribute of ID, an attribute of first name, last name, and address. Each row represents an instance of my customer. Any questions on kind of the tabular structure and data? Any questions on kind of conceptually how that is? Can you guys put a 1 or a 0 if tabular data makes sense? Cool. Yeah, fairly straightforward. All right. Non-relational databases operate differently, right? Each instance here, each instance must contain, not necessarily contain, but it has each column. So in this case, my customer, every customer has a column for first name, last name, and address. Now, sometimes, let's say we had a middle name here, and some people just don't have a middle name. They don't want to. Or some people don't have a last name. Think of like Seal, right? If I was storing Seal, who just has one name, I guess it's their first name, in my database, the instance that is Seal would be, have an ID number, have the first name of Seal. They would still have this column last name. It would just be empty. It'd be what we call null, right? There's no value there. But that instance still must happen. With a non-relational database, that's not necessarily the case. But just wanting to reiterate, a relational database is a tabular way to store data. Each column represents an attribute, and each row represents an instance of whatever that table is. In this case, it's a customer. Cool. Cool. Now, there's some design when we're thinking about this that I want to jump into, some sort of conventions. Actually, no, let's jump into the relationships because I think that would be the most sense. All right. So there's 3 different types of relationships when we're talking about a relational database. We've got a many-to-many, a one-to-many, and a one-to-one. I'm going to start on one-to-many, many-to-many, and then we're going to talk about one-to-one a little bit. One-to-one is more of a unique thing. It's not something that you typically will use a lot of, and especially in this class, it'll be very, very scarce that we ever use a one-to-one. The 2 that you need to know are the one-to-many and the many-to-many. So we're going to really focus heavily because also all of our assignments, and typically in the real world, most of the relationships are a one-to-many or a many-to-many. Okay, so let's say I have got I'm going to do it this way. Let's say I've got 2 tables here. One is going to be my book. And the other one is going to be a publisher. Okay. And this book is going to have some values. So it's going to have an ID. It's going to have a title. It's going to have a release date. And then my publisher is going to have an ID, a name, address. I'll just say that. Okay. What a one-to-many relationship does is, if we think about it, let's say I'm creating this application, right? And what I do is I have books and publishers, right, within my application. What a one-to-many relationship does is it decides the relationship between two tables, right? Any sort of relationships is either a one-to-many, a one-to-one, or a many-to-many. Hence why we call this a relational database, right? It's a way that we can connect our data together in different ways. So if we think about it, my publisher or a book can have one publisher, right? If you really think about it, I'm sure that there's ways to put it. Let's do this. My book can have one publisher, but my publisher can have many books. Think about it. A publishing company would be pretty poor if they just, all the publishing company did was they just did one book, right? That's all they did is they just did one book. That'd be a pretty poor publishing company, right? Publishing companies do a ton of books, but a book can belong to one publishing company. This is what we call a one-to-many. One publisher can publish many books. Each book belongs to one publisher. Does that make sense? So my publisher can publish many books. A book can only belong to one specific publisher. Now, that is what we call a one-to-many relationship. Let's pretend now that I've got this other table. I'll do it in this. And this table was authors. Right? I have two instances of authors. A book can have many authors, right? If we think about like a textbook, if we think about, kind of any sort of book, right? A book can have just one, like a J.K. Rowling. Or if you think about a textbook, sometimes there's like 7 or 8 publishers. So a book can have many authors. And is a author limited to only writing one book? No, right? An author can write many books. So this author can be associated with this book, and this book. This author can just be associated with this book if it wants. And what this means is this would be what we call a many to many relationship. My book can have many authors, and my author can write many books. So when we're creating this database, I can set this up in such a way that this table, my table of authors, is related to my books in a many-to-many way, allowing for my book to have many authors, my author to have many books. And I can set it up to where my book can have one publisher, but my publisher can have many books. Now, I know that this is a lot of theory. We're going to get into like actually building it to where it might make sense, but are there any questions kind of on this for right now? On just the general outline of one-to-many, many-to-many? Cool. Lots of ones. All right. So here there are videos that talk through this, but here's where we talk about kind of this and customer and order is kind of a hard one because yeah. But if you think about it, here we're just showing that a customer can order just one thing, but it can also order multiple things. If you think about Amazon, right? I might have multiple different aspects of an order. Cool. Now, before we get into normalization, I do want to start talking about the attributes of a table. So whether it is a one-to-many or a many-to-many table, if we're creating a table, there are some guidelines and things that we must have for every single table. Now, I do want to point this out. These are general guidelines that are great. So as you guys are creating this here in this program, or you're creating your own things, these are some things that I would say you need to stick with. There are some things that are definite you have to have. But I will say that there might be times, let's say you get into the real, you get into a job and your company has maybe different guidelines on how to name a table. Okay. If that's the case, then, follow your company's guidelines. Or maybe a naming convention is different, follow your company's guidelines. But until you really kind of are told differently, these are some of the things that you absolutely should be doing with every single table that we have. Now, one thing I want to note is Flask. We've talked about this. Flask does not use an ORM. Now, if you took Django, you're familiar with an ORM, and an ORM is an object relational mappers. What it does is it actually can create, and there's ORMs not just in Python, they're in all kinds of different languages. But it's to where what an object relational mapper will do is it will have some built-in functionality that will set up a lot of this for you. It'll make it to where you actually don't have to run the actual queries. You just say, like .get, and built into that code, you're using functionality that runs that SQL query specifically on what you're trying to do on the format that ORM gives you. Now, we're not using this, so we do have to be really careful with a lot of this stuff. You can get away with a lot of stuff in an ORM in the sense of you don't create an ID as a primary key. It's just already a built-in thing. But these are the things that we really, really, really have to focus on whenever we are building this table and we're building our database. Now, just so you know, there are entire jobs like a data engineer that builds out databases, right? And so if you're interested in something like that, then yeah, you should absolutely dive into this. There are other jobs, especially if you're working at like a smaller company, you're gonna have to wear many hats, right? You're probably gonna have to deal with database stuff. But just know that database and setting it up now and early can help you in the future. So let's go through some of these guidelines. First one is make a table name plural and all lowercase. So if you're creating a table, in that example where we had book, right? In the ORM, I got kind of confused because you usually just do one instance with a capital B. But what you are actually supposed to do is you are supposed to, and this is just a base guideline, is make each table name plural and all lowercase, no capitals or anything. So if we were creating a user, it would just be a users table, leads, sites, etc., etc. Another thing we would want to do is we want to use ID as the primary key. Now, when we actually create an ERD in MySQL Workbench, it will typically take the table name and say like, users ID or ID users. So I want to make sure for us, we just want it to be ID, not the actual name of the table. And we also want to make sure it's auto incremented. So for a relational database, you can think of the ID as a social security number, right? Each two instances might have some of the same information. There are multiple Michael Jordans out in the world, right? Only one of them is the second best basketball player in the world or in the history of the game. That's a hot take. That's okay. But what makes them unique? There's only one Michael Jordan who played for the Bulls who has the social security number that MJ does, right? And so this ID, you can kind of think about it like that. This is my unique identifier. This is what makes me say, well, I don't want just the book or the user named Michael Jordan. I want this specific Michael Jordan. And the ID is going to be the unique identifier we call to whenever we are trying to query and pull something from my database. Now, whenever we're talking about relationships, and I had this book and publishers, I didn't go over it because we hadn't gone over the attribute stuff yet. But one thing I want to note is when we are creating this relationship, we will also create something called a foreign key. What a foreign key does is it is an attribute that controls the relationship and signifies a relationship between two instances. let's say I had a publisher table with a bunch of, 10 rows of publishers. I couldn't tell you a single publisher. But let's say, publisher with an ID of 2, right? And then let's say I have Harry Potter. Well, the way that I can connect this publisher to this book specifically is through what we call a foreign key. Again, this is all theory. We're going to see how this works out for the back half of class. So please stay with me if this is getting kind of confusing. You'll see it a lot more here in a bit. But what this does is it references the relationship and declares the relationship between 2 tables. And the way that we'd want to do that is we want to say the singular table name. So if it was users, I would say user, because we're talking about one user instance underscore ID, right? Just like this. And then lastly, and this one's super important, and this is one that's easy for people to forget, but do not forget this, because a lot of headaches down the line can be, and a lot of queries down the line can be really alleviated just by doing this. Each time we create a table, we want to make sure that we add a created at and an updated at. 2 reasons why this happens. Let's say I want to see how long somebody's been a member, right? How long somebody's been a member at T-Mobile. We're just going to pick on T-Mobile for a bit. I want to see how long has somebody been there. Well, when I created the account in my database, if I have a created at, I can just do a query, right? Of, the date when it was created at and the date now, and then see how many years are in between. And then I can say, hey, thank you for being a customer for the last 7 years. That's a great tool. But then think about it too, of let's say all of my users, created after January of 2021 are susceptible to a database breach. I can use that information to reach out to the users who might be susceptible and say, hey, your stuff might have been stolen. Same thing with this updated app. Let's say that I edited my account and I updated it. Well, what I can say is, account last updated this time, right? If you think about your password, when your password and you have to update it in like a Facebook or some other thing, like NordVPN says, all right, it's been long enough. You have to do a new password. It's utilizing this information, right? When was the last time it was updated? Specifically, this information. When was it last time it was updated? Okay, great. It's been 45 days or 60 days. Now let's ping them and say, it's time to update it again. We got to keep your security. Or same sort of thing of when was it last edited? If you think of like a Google Sheets, right? Last time I edit something, it'll say last edited 2 hours ago, right? It's taking that information. That way I can query it and I can see it and be like, oh, somebody hasn't worked on this for the last 10 days or whatever. So making sure that we are utilizing this created at and updated at whenever we are creating an actual table. Any questions on this? Would it be worth creating a one-to-many relationship for updated at? I just feel like it'd be good to have a log of updates. Oh, that's a great question. I'm sure that. That's a great question. Let me think on that. Because I think that there would have to be a way that you could. I think you would probably create an attribute that was. Oh, that's a great question. Likely. But let me think on that. That's a great question. Cool. Any questions on these guidelines right here? Again, I know this is a lot of theory. We're going to jump in and then you'll see a lot of this stuff. Cool. The other thing I do want to talk about is when we're actually creating our tables, we've got some pretty simple data types that when we are dictating and saying, okay, in my information, these attributes are going to be a specific data type. So when it's saving it in a particular way. One of the data types is a varchar, which is used to store non-numeric. So you can kind of think about it as a string up to 255 characters. That's the limit, right? That's the limit of memory that you can keep in a varchar. Now, if you store a particular size, let's say you don't do 155 characters, let's say you just do 100 characters. Okay, it'll store something in from a memory perspective at 100 characters. Okay, you have a limit of 255, but you can store it at 100 characters, and they'll store that in memory at 100 characters. That's what a varchar is. Secondly, there is what we call a char, which is a number of characters. Now, you might say that sounds exactly the same. Well, what this does is I will pass in a number. So with varchar, I'm going to say, name 50 up to 255, and then it can go up to 50, but it stores what it's supposed to be. For a char, what's interesting about this one is I can put a number in there, and no matter what, whether somebody passes one letter or all 50, it will use up all the space of 50 characters, which doesn't sound like a lot. But if I am overestimating, let's say I'm saying, in this case, you could think of like 15, and I'm only using coding, but I've got 1,000 customers or 1,000,000 customers, I am taking up so much more space than needed. And then space is money because I'm storing this on some server in the cloud, likely. Right. And so char is something great for maybe like a phone number. Right. I know that in the US, a phone number is, what is it? 9, 10, 4, 8, 11, 11 characters long with an area code, right? 10. Thanks, Peter. It's 10 characters long. So I know that a phone number is going to take that up. It's not going to take up more or less. So that'd be a great thing for char. Then whenever we use numbers, we use something like integers. And you might wonder, why did I not say a phone number should be an integer? Well, an integer is really something like, I'm never going to add the number 7 to a phone number, right? That's just not any sort of like arithmetic that I'm going to do. But if let's say I want like number of followers or some sort of number, maybe age, I want to add each year, I want to add that this person's age goes up, I can store that as an integer. Now, there are two ways that I can do that. I can either do an unsigned or assigned. What that basically does is they're the same size in the sense of how much memory they take up, but what signed allows is for a negative number. Again, they look different, but from like a memory perspective, they take up the same. But because we're in negatives and this one starts at 0, that's why it looks like this. But what unsigned does is it's positive numbers only, right? So even these IDs, we're never going to get to like a negative ID number. It's always going to be positive. So this can be unsigned. Versus signed is a number that can be either positive or negative. And then secondly, there's big int and tiny int. They are what they sound like. If I want to take up a massive amount of space, or if I need to prepare to take up a massive amount of space, I can set it as a big int data type. If I know that it's kind of like char, going to be just a very, very, very small number, then I can use a tiny int. The example it used here was like basically if you knew like a employer's or an employee's status and what they had access to or not. So like maybe 0 is inactive or active or an admin, right? Based on that, I might just use a tiny int because I'm never going to need, a larger amount right here. But that's what you can do with tiny int. And then they can both be unsigned and signed, meaning can be both positive and negative or just positive. All this sounds kind of like, why are we learning this? But when you're dealing with databases, you're also dealing with data, right? And you're dealing with setting this up. A lot of databases are on the cloud, or you're on your public server and you're paying for server space. So when we're really setting this up, we want to be as accurate as we can. That way we're utilizing our information, or we're utilizing our space as best as we can. The other types are float. Float would be like your decimal number. Text here is a varchar. Or not a varchar, it's just a text. Sorry. A text can be any sort of, varchars up to 255 characters. Text can be anything. If you wanted to upload a novel, you totally can. This can be great for something like an Amazon when somebody is leaving a comment or a review of a product. That would be something like a text. Some reviews are like, hey, this is great. Other reviews are like, when I was a young boy, my grandfather looked at me and said, one day, you should buy this, right? And then they tell this long story. We don't know. And so that's where a text would be. And the last one would be date time. This gives you the date and time. Kind of makes sense. In this specific format, this is what our created at and updated at are going to be like, or that's the type that our created at and updated are going to be whenever we create those. Any questions on these? I know today feels a little bit dry. It's a lot of theory. And not necessarily theory, but it's a lot of just like understanding an ERD before we can go build one. And then as we start building and then we start doing queries, that's where the fun comes in. Cool. And something to note in here is Christiani was talking about character 5 for zip code limits you to the US though. That's a great point. These data types can vary depending on what you're wanting to do in your program, right? If you're wanting to do something that's international, right? Maybe this char is different versus if you were doing something like just the US or just one city versus, you know, something larger. And so your database can change on whatever you're trying to accomplish, right? There's no sort of like, oh, cookie cutter, every database looks just like this. No, it depends on totally what you're trying to do. What kind of data are you trying to save? What is the point of your application? What is the point of you even saving data? So whenever we are creating these, we just have to realize that we can create them in such a way that it actually is unique to our application, not just some generic sort of way there. Great point there, Christiani. Cool. Now, the last thing, and then we're actually going to dive into Workbench, is talking about normalization. Now, one thing I do, this is what I really want to point out, is it is possible to take normalization to an extreme. What normalization does is it's trying to create the most efficient database that we can. And what that does is, and what that means, and what it's trying to accomplish is that we do not repeat data. So let's say I have two users who live at the same house, right? Either they're roommates or their spouses or partners, or whatever. Well, if I have a user table, right? And this user has, you know, a first name, a last name, and an address, instead of me sort of having this, instead of me having this address of, you know, whatever this address is, and then the other user having the same address, I can actually create an address table and then just refer to that. Instead of having to repeat it, I just have one address in my database and I just refer to it with each user. So I'm not taking up as much data. Again, this will look a little bit easier whenever we are talking of and actually building our ERDs, but that's what normalization is talking about. Basically, do not repeat data. There's 3 different forms where the first one, your address. So like in this case, address, if it was like the number, comma, city, comma, state, we wouldn't want any sort of commas, right? So each column just has one bit of information, whether it's the actual address or the city or the state. And there's a great video kind of explaining that with normalization there. All right. I've talked a lot about this. Are you guys ready? Are there any things I need to clear up? Are you guys ready to get in some ERDs? So Peter asked, are there major efficiency differences between using shorted varchar like varchar 100 versus 255? Yeah, when it comes to like a memory at a larger scale, absolutely. Yeah, because you're limiting the data, right? So you can think about like, it sounds stupid, but think about Twitter. Twitter limited to 160 characters, right? Because if they didn't and they're storing all these tweets, that would be so much more money. If people could just do an entire rant, right? If they could do 500 characters per thing from a storage perspective, you are storing all that information. And so, yeah, absolutely. It does from a large, especially as you scale up, it saves you much more money. Like if you have like 100 users, you probably won't see that big of a difference transparently. That compared to 100 million, you will absolutely, as you scale up, see the difference there. Yeah, so I would say, so Peter also asked, so it's worth limiting things like names and stuff to something reasonable rather than giving the full 255. Yeah, absolutely. I would say something like 50, which whenever we build these out, 50 is like a pretty average and normal per name, in the sense of like first name is 50, middle name 50, last name 50 is pretty 75, 50-ish. Just because as a reminder, right, we might think wherever we grew up or whatever our life kind of background is, like, oh yeah, 12 kind of makes sense, right? 12 characters, huh? My name's Will, like whatever. But people have different names, they have hyphenated names, and so we want to make sure we are all inclusive for everybody. That way our application runs well. Cool. So one of the big things that you did have to do, and here it is you had to download something called MySQL Workbench. So if you downloaded MySQL Workbench, it's going to look something like this. And if you didn't, if you're on a Mac and you were having some issues in our office hour, we do go through how to build this. But once you downloaded MySQL and MySQL Workbench, you should have something like this. When you open up MySQL, you have maybe just one instance. I just created a different one for something else. But you should have this local instance here. If you don't, you can actually just click this button right here, and this will create it. You don't need to change your host name or port. You can just change your connection name. Now, this username comes from what you did, but then also you must remember the password. So when you are creating this, when you're creating your and downloading MySQL, you are putting in a password. Make sure you remember that. Do not just randomly put, some like keys, because we need access to that password, not only for what we're doing here, but then whenever we do Flask, we're going to need access to that password as well. Which actually brings up a second point, is when you are creating these passwords, I would encourage you, don't use something in like your normal password that's going, if you have 1 or 2 or 3 passwords that you kind of rotate through every website, don't use one of those. Use something like root, use something like root if you can, because when we get to Flask, we're actually going to have to, in our connection string, put that password there. So please make sure that you, I am root. Please make sure that you just do something, kind of normal, like a root or a root group. But once you download MySQL Workbench, you're going to come here. Cool. And if we're creating an ERD, which is what our homework is today, I know today seems a little boring and I'm sorry, but we're getting there. What our homework is asking you to do is to build an ERD, right? And what that is in our, it's just a visual representation of the relationships within my database. So in this exact one for Dojos and Ninjas, it's saying design ERDs with one-to-many relationships. So I'm going to create 2 schemas called Dojos and Ninjas, or create a schema called Dojos and Ninjas schema. And then in there, I'm going to create a table. How do I do that? So what a schema is it is just my database in itself. In this case, I'm going to come here to this guy right here, right? And I'm going to click on this models. In this models, I am now, here is my physical schema. It's my database, right? And so what I want to do is I want to create a new diagram. When I create a new diagram, it's coming here. This says my DB, but I'm going to call this Dojo. I'm going to call this book publisher. This is me creating a database schema within MySQL that now has tables and then views and routine groups. You don't need to worry about that. But we are going to now create tables within this schema. So let's go ahead and create my book. So I'm in my workbench. And again, how I got there is I just clicked this guy right there and it took me, and then I created, it said add diagram. But now I want to create my book table. So this guy right here, place a new table. I click it. Let's just do it right there. This is my table 1. I have now created a table within my database called table 1. If I double click it, I can create and change it, remembering that we the first guideline is that we do a plural version, all lowercase. So now I have changed it to books. Perfect. So now even if I come here, this table is now called books. Now, if I double click it, here is where I can actually add my columns, my data types, every bit of information. What else do I need to have whenever I create this? What is one of the main things I have to have? An ID. Yeah, way to go. So I'm just going to call this, double click, and I just see how it automatically said ID books. Just remembering we want to call it ID. Now it is of type integer. This is my primary key. The reason it's my primary key, right? You can kind of think about it like a social security number. This is what is my unique identifier. What this NN is saying that it is not nullable, meaning this field cannot be empty, right? If I have an instance, it has to have an ID or else I have no way to reference it. And then the last thing I want to do is this AI. What this AI is doing is this is auto incrementing. So my first instance is going to be the number 1. And so on and so forth for all my users, and 1, and then the next user's 2, and so on and so forth, and so on and so forth. So that's where this AI comes in. So it's auto incrementing. Awesome. I have created my first column. If I come here, you can see that this book has an ID event. Let's add some more stuff. Let's call it a title. Varchar. I don't want it to be 45. Let's say 75. And not nullable, meaning book has to have a title, right? Book can't not have a title, but it's not my primary and it doesn't need to auto increment because it's not a integer. So cool. What else can we create for my book? Any other attributes? What do you guys think? Author. Okay, we're going to get there. We're going to have our own author table. Anything else for a book? Let's just say release or ELEA's date. And let's see what types we can do. So here I've got a date time. That's probably what I'll use. I can use a date. I'll probably actually use date. There's all kinds of different things, right? We just talked about a couple of them. And you're not going to use most of them. One thing I do want to note is there is a decimal data type. So if you're working with money, typically you do want to do a decimal and not a float, just a heads up. But let's go ahead and just say date, not nullable. Now there's 2 fields that I must have when I'm creating this. What are they? 2 more fields. Oh, genre is a good one. Or description. I like description because genre is a description. And let's actually make that one. What do you think? Should we do this varchar or what else do you think we could do this? Create it out, update it out. Yeah. I say we don't do varchar. And we do. Yeah, we can actually say varchar because I don't want to. Not too much. Let's say 150. Perfect. Not nullable. And then, yeah, you guys hit it right on the head. I need to create it at. This is going to be a date time. Update it at. This is going to be a date time. Perfect. So now my book, I have this guy right here called books that is got an integer, right? So it's got some ID, it's got a title, it's got a release date, a description, a created at, and an updated at. Awesome. Now let's go ahead and create my publisher. Again, I just do this guy right here. Let's go to publishers. Let's do an ID. And primary key is auto incremented. I'm going to say name. Varchar of, I like to do, I don't know why, I like to do 75. Not nullable. Let's say anything for publishers. I think created a. I think publishers is fine for what I'm trying to do. Cool. Okay. So now I have got this schema that's got my publishers and my books. And we've talked about how my publishers can have many books, but my book can only belong to one publisher. So that is where I'm going to declare this relationship. Now, if I look here, there's all kinds of different things. I've got my dash 1-to-1. I've got my dash 1 to n. 1 to n means 1 to many, right? I don't know how many it is. It can be 0 or it can be 1 to, many of them. And then my different sort of types here. And then I my n to m, which is my many to many. But in this case, I want to do a 1 to many. So what I do is I grab this and I'm going to start on the many side and I'm going to go to the one side. So come here to here. And you can see that it created this line for me. And this line adjusts, kind of moves wherever I go. It's kind of sweet. But it created this line for me. And there's a couple of things that I want to point out here. With this line, if I'm building this out, you can tell, let me try to, that it has the kind of pitchfork looking thing on the many side. And then it goes straight into the one side. And so when we're creating these ERDs, making sure that this M, I kind of see this pitchfork look like an M. This M is on the many side, right? Many books to one publisher. And so this declares a 1 to many. Now, when I did this, by default, it added this attribute right here where it says publisher's ID int. This is what we call my foreign key. This is what is taking for each instance of my book that is created. It is taking a publisher's ID and applying it to that book. So that way my book belongs to a publisher. It is my foreign key. It is what is connecting me together, connecting this instance of book to that instance of publisher, whoever is publishing that book. Any questions on this 1 to many side? Easy way to move the foreign key to the top near the ID. I don't know. Let's see. I can look into just like changing it. It works just fine. If you keep it, oh no, I don't want to do that. If you keep it this way, it works. It does work fine, but I'll look into how to actually like change it if you just like aesthetically what it looks like. But it's a great question. Cool. Okay, so now I also want to create this many to many side. So if I'm doing this, we talked about how an author can have many books and a book can have many authors. So let's go build my author table. Authors, that's got an ID, type int, it's got primary key, auto increments, and then I've got a name. Maybe I'm gonna say first name. Last name. And then not nullable. I've created that. Updated that. Cool. So I've created this authors table here, and we've talked about how we want this to be a many to many, right? Many authors can write many books. A book can have many authors, and an author can write many books. So here, what I'm going to do is I'm going to grab this NM and click it, and then I'm going to connect the two here. And what I want to point out is what just happened. So here I have connected the two, right? To where a author can write many books, doesn't have to, created one. It can create one or it can create 100. And a book can have many authors, but it doesn't necessarily have to. And for a many to many, there's not a really good way or a foreign key in that stance, a foreign key cannot be like a list, right? And so let's say my book does have many authors. Well, I can't create a list within my foreign key. So what a many-to-many does is it actually creates this third table here. Here it says authors has books. It's because I clicked on authors first and then went to my books. And this third table is what actually keeps track of my author's ID and my book's ID. It's what creates our relationship. Anytime we do a many-to-many, it creates a third table that automatically that allows us to have many books and many authors. That way, let's say, myself and Mel write a book, and book is called How to Do Okay at Flask. That book might have an int of 5, right? Which is its identifier. In my database, it is the 5th one, or it has an ID of 5. But maybe my ID is 3 and Mel's ID is 1. Well, each time that relationship's created, in this authors has book, we're going to have 2 instances, right? One that has my ID and the book ID of 5. And another instance that has Mel's ID and the book ID of 5. That is what allows this many-to-many to happen, because there's no way for books to have publisher's ID or author's ID and then have both IDs. This has to create this third table that allows there to be certain instances and to connect the 2 tables together. Does that make sense? Yeah. So Kevin, through this, and that's something we'll kind of jump into when we do queries and we start diving in. But yeah, through this authors, you can kind of think about it. I like to think about it as like a doorway, right? So if this is getting a little bit ahead, but if from my author, right, I wanted to go into my books, all the books associated with my author, I totally can. And this acts as a doorway to give me access to all the stuff within my book. So not only can I just get a list of my books, but if I want to jump in there, I could jump into, the release date of my second book or something like that. So yeah.
I'm not sure if I missed what you may have said about this, but how does the primary key work for that intermediate table? Because so it uses those 2 IDs as the primary key. Am I getting that correct?
Yeah, let's go look at it right here.
Because I guess I was under the impression that, it's that one ID that pretty much identifies that individual item. But in this case, it's those 2 IDs or that combination of the 2 IDs.
It's the combination of the 2. Kind of like what I was saying with, let's say, I'll just draw here. Sorry. Okay. So if I have this, sorry, I don't know what it keeps doing. Okay. So here, let's say Mel and I write that book. This is just the middle table that allows these 2 to be connected. So it doesn't have its own sort of qualities in it, right? It's not its own table in the sense of it's got an instance like these do with an ID. But this is what allows me to create this relationship between these 2 primary keys by having them sit here.
Also, what's the difference between identifying and non-identifying relationships?
What do you mean?
It's those buttons you have for creating the relationships. There's one that's the dashed line, and then there's one with the solid line.
Solid line. Yeah, I don't quite remember the difference between these. The dash line is what that's what I've always used. That's what I would continue, or I would suggest that you guys use. I don't quite remember. Because I don't deal with it very much. I don't quite remember, but I can look into that.
Okay.
Cool. Any other questions? Mel, are those links for that question?
Yeah, so the second one, the second link for data dynamic just briefly goes over identifying and non-identifying. And I thought that it gave a pretty good rundown as far as it
Cool.
saying that, I don't know if you want to read through it.
Yeah, not right now, but
Yeah.
there are those links and we'll put those in the Discord channel for that.
Cool.
Are there any questions on just kind of setting this up? All you'll do now, once this is done, because you have your ERD, you can come save it. You can save it as a document, or you can export as a PNG. So for your assignments, whenever it's asking you to create these ERDs, so for your first two assignments, you're going to come and create them, and they're going to export as a PNG. And then let's see. Peter, you raised your hand.
Yeah, I feel like you might be getting there, but in terms of like, obviously you save the PNG. If we want to save this actual like model workspace, whatever you want to call it, do you recommend we save it in like a set place in documents, or do you recommend we save it in each project folder?
No, so if you save it here, you have this schema of book publisher.
Okay.
And so if
Yeah.
I were to, oh, I don't think I've saved it yet. But
Yeah,
yeah,
well, that's and that's why I was wondering where would you save that to specifically? Is there like a certain location that you're supposed to, so the program picks it up, or like it doesn't really give you?
Yeah, it
Sort of just
doesn't.
sticks me in documents.
Oh, I see what you're saying.
Yeah,
So,
yeah.
oh, I see what's happening. So, sorry. So we're going to create these ERDs and we have them here. And then, yeah, you can save them as a document. What we're going to end up doing is we're going to do this thing called forward engineer. And so this is creating an ERD, which is just kind of like an outline, right? A wireframe, if you will. When I do this forward engineer, there's actual SQL code that it will write. So like I'll walk through it. To where I can do a bunch of stuff. This is SQL code. I'm not going to do that. There's nothing I need to click. Export tables, because I didn't create views. Views are basically like if I'm searching a table and I want specific things to look at, that's a view. And I just say, continue. This is the SQL code, and it's actually going to write it for you to where you do this. And then we say finish. This is what we're going to do on Wednesday. And then if I come here, it will, I think I have to go my instance, but whenever we forward engineer it, it's actually going to write the code and then create the schema. That way it's actually in my database. Because right now it's just an ERD. It's just like a wireframe, if you will. So on Wednesday, we'll forward engineer it to where it actually is then saved.
Okay, so you're not really, I guess for these current things that we're just creating them, just export the PNGs and save that aside and don't really worry about doing anything else.
Yeah, because we're going to forward engineer and actually create database schemas.
And that'll be on MySQL server end then, I guess, right? Is that where it's saved? Okay.
Yeah, because right here is my, so even right, I click out of it. And then if I on my SQL model here, I can, I have this diagram. So it's already saved here. And then what we'll end up doing is forward engineering this to an actual schema on MySQL. Any other questions, friends? Great questions today, though. I know that this was probably the hardest lecture in the sense of just sitting there because it's just me giving information. We're not like coding or doing any of this, but this is just setting up for when we do forward engineer and we start doing queries. You'll have an understanding of like, okay, this is the foreign key. Okay, this is the attribute. Okay, this is what I'm doing. And where we actually are dealing with our schemas and our databases, which is our schema. So other than that, friends, I don't have anything else for you.